The next common mistake in Angular programming that we're going to discuss is not so much a mistake as it is a really bad choice. I've heard a number of reasons why developers choose not to use reactive programming in their Angular applications. Everything ranging from some developers prefer working with promises over observables, and others just find reactive programming very difficult. And not just reactive programming, but working with the RxJS library and observables. And that's understandable. It can be challenging working with observables and the RxJS library, and therefore implementing reactive programming. But the fact of the matter is that in avoiding reactive programming, you have to do, no matter what implementation or programming paradigm you choose, you have to do a lot more coding using the Angular framework. And that's because essentially Angular is built with observables in mind. The HTTP client is built around observables. The Angular router is built around observables. Reactive forms, guards, all of those Angular features implement observables in some way. And when you're working with observables, the better programming paradigm to work with is reactive programming. Let's take a look at this example, which exemplifies how imperative programming differs from reactive programming. And let's first take a look at the imperative programming style. In imperative programming, you typically have a publicly accessed property, such as we see here with the customers array. You have a publicly exposed property that is constantly being updated by either user events, such as filtering, or the addition of a new customer, or the modification of an existing customer. And with each user event, the public property has to be updated. And we can see this in the ng-on-init method, as well as the add customer method. We always have to call this load customers method. And the load customers method, via calling the subscribe method, it retrieves the customers by making an HTTP GET call, which is handled by the API service. So this is typical of imperative programming, a publicly accessed variable that's being updated with each user event via some subscription. And what we have in this current version of the load customers method is we have not only the retrieval of the customers by calling the subscribe method, but we also have to loop through each customer to make yet another individual backend call for each customer to retrieve the accounts for that customer by making this API service backend call to the get accounts by customer ID method. And of course, that is an observable method, and an observable method must be subscribed to. So we subscribe to that method as well. Now, what we have is what's called nested subscriptions. We have this first subscribe to all customers, and then we have a subscription nested within that all customers subscribe. This is very common to imperative programming in Angular. And with every backend call that you make to retrieve the data that must go into the display, with all of those subscriptions, they'd all be nested in this manner. Now, when you get nested subscriptions, you get a couple of things. You get code that becomes much more difficult to read, much more difficult to reason about, and much more difficult to debug whenever you have to debug it. And not only do we have these nested subscriptions, but we have to do things to ensure that we get a good user experience. And that's what's occurring with this use of this customer counter. When you have nested subscriptions that are occurring within a for each loop like this, well, observables are asynchronous. The data comes back in varying points. And in fact, you could get the accounts retrieved for the third customer before you get the accounts retrieved for the first customer. So in summary, you never know when you have all of the accounts for each of the customers. There's no way of knowing that because this code does not run synchronously. So what you need is some sort of counter to tell you when you've retrieved all of the data for each of the customers. And that's what we're using. And it's only at that point when you're certain from this counter that you've retrieved all of the data for each of the customers that you then set the public property. Because if you set it before the data is retrieved, well, then your display will be populating data at varying points. So you'll have accounts coming in for a first group of customers, and then you'll have more accounts being displayed for another group of customers. And that makes for a very bad user experience because the user has no idea when all of the data is retrieved. So another negative aspect to employing the imperative programming style is that you do have to sometimes implement additional code to ensure a good user experience. So this example shows us what it's like to use imperative programming. So now let's take a look at how we perform this same operation using reactive programming. So I'll just expand the code under the reactive programming pieces. And immediately you notice that there is a lot less code in the reactive programming style. Here in this customer's observable property, we're retrieving data from the same all customers observable, but instead of subscribing to the observable, we are doing our subscription via an async pipe in our template, and that async pipe will subscribe to and unsubscribe the customer's observable. Within our pipeline for the derivation of this customer's observable, we are doing in 4 lines everything that is being done in over a dozen lines in the load customers method. We are retrieving the array of customers, the entire array of customers from the API service. We are looping through each of those customers via a concat map and from operator, and then we are calling the individual get accounts by customer ID observables for each of those customers using a merge map. So we are performing the same operation in fewer lines of code. And not only do we have fewer lines of code, but we have code that is very linear. There's no nesting here. Well, you might say that there is a nested pipeline here to map the accounts to the original array. And you know what? You'd have a point. This is a nested pipeline, but the difference between this nesting and the nesting of subscriptions in the load customers method is that we don't have to concern ourselves with the asynchronous nature of this get accounts by customer ID impacting our display or the updating of our display, because this entire pipeline will only ever emit one value. It's not going to emit multiple values and therefore have the customer's observable emitting multiple values, which will be seen by the users. It's only ever going to emit once, this entire pipeline, despite the fact that we do have a pipeline nested within the pipeline. Can this be a little bit difficult to reason about? Well, this is actually a common pattern that we use in reactive programming. So when you've done it a couple of times, you get to know it as a pattern. It's not something that you'd have to reason about each and every time. This is something that we do often. But again, it's a lot less code. We don't have to do any kind of tricks to have our display update properly and just once. All of that is done via the reactive nature of observables. And as you can see, when we add a new customer, we simply add the customer via the observable method. When this observable method emits, it will cause an emission in the all customers observable. So all of this happens automatically and reactively. User events such as adding new items causes an emission, and that emission will cause other observables to emit, and we don't have to have these manual calls to methods to get our display to update after each user event. Now, there is the upfront cost of learning reactive programming and learning the RxJS library and learning how to work with observables, but you only do that once. For the one-time investment of really getting to know reactive programming and the RxJS library, for that one-time cost, you reap the benefit of having to write a lot less code and having your code be much cleaner and much more easy to extend and much more easy to understand. Now, if you've tried reactive programming in the past and you just found it very difficult to get your head around reactive programming and observables, I've actually created a course that helps you learn both the RxJS library as well as reactive programming. It's a very comprehensive course, and it starts at the beginner level and progresses on through to the intermediate and advanced levels of reactive programming. And the course has received a lot of wonderful reviews. And my students who have taken the course actually use the course as a reference in their daily work, because not only does the course include lectures on how to use all of the RxJS features, but it also offers a lot of custom code that I've written that you too can use in your code. So again, if you're interested in beefing up your knowledge of reactive programming and RxJS, there is a link in the description of this video to my course. And if you take it, I'd love to hear from you and hear what you think of the course, and if it does indeed succeed in helping you better understand what I definitely know to be a difficult topic to learn. Please do subscribe to the channel so that you can receive notifications on our upcoming videos in this series. Until I see you in the next video, keep on coding.